In many situations, we need to synchronize threads that are running inside a process. Earlier, you have seen how semaphores can be used to synchronize processes. Now we will see how semaphores can also be equally effective in synchronization of threads. The interface is slightly different because we are using a slightly different kind of semaphores. These semaphores are unnamed semaphores. Previously, with processes, you were introduced to POSIX named semaphores. These are known as POSIX unnamed semaphores. The reason being that they do not have a name or a file name specifically to identify them. So the interface is slightly different. Instead of semopen, we have seminit over here. Then semwait and sempost are there for the operations on the semaphores. And instead of semclose, we see that we have semdestroy over here. Okay, first we will have a look at seminit and understand its parameters. The first parameter is used to specify which semaphore should be initialized, and the programming example will clarify the use of this one. The third parameter, named value over here, is used to specify the initial value for the semaphore. Remember that for effective use of semaphores, it is vital that the semaphore is initialized to a correct value. The middle parameter of seminit, named pshared over here, is used to indicate how this semaphore is to be used. Unnamed semaphores can be used between threads or between processes. If this parameter has a value of 0, then we indicate that the semaphore is to be used between synchronization of threads. And the important thing is that the semaphore should be at some location which is visible to all threads. Remember that a lot of things inside a process, like a global variable, are accessible to all threads of that process. Also mentioned in the documentation is that these unnamed semaphores can be used if synchronization is required between processes. In this case, the value of pshared should be some non-zero value. Moreover, the semaphore should be located in some shared memory region. Remember that processes by default cannot look into the memory space of each other. So if there is supposed to be any quantity that is visible to more than one process, it has to be placed inside a shared memory. For our case, we will have the value of pshared equal to 0 because we are interested in using these semaphores with threads. Upon success, seminit is going to return 0. In case of a problem, -1 is returned, and the global error variable error number is set to indicate the error. The other new function over here is semdestroy, and the only parameter to semdestroy is used to specify a semaphore on which the destroy operation is intended. The semdestroy operation is performed on a semaphore when it is no longer needed. It is important to remember to not mix up the two kinds of semaphores. Specifically, if you are using named semaphores, then you have to use semopen, and when you are done with the semaphore, you must use semclose. However, for the unnamed semaphores that we are going to use in an example very soon, seminit is used to initialize such semaphores, and when they are no longer needed, semdestroy must be used on them. So to sum it up, we have semaphores over here which are going to behave just like the semaphores we have seen earlier. The programming interface is different, slightly different. Only seminit and semdestroy are new. Semwait and sempost are just like the operations which we have seen earlier for named POSIX semaphores.